everything you know about these different shapes. So it says fill in the formula for finding the area and the shape of the chart and add additional information to remember. So it's crazy in mathematics. We try to find the balance between how much do I need to have living in my brain permanently, how much is just renting space while I need it and then vacating during the other areas of my life, and what do I not need to hold on to because I can always go look it up. So the interesting thing is with my calculus kids, we're doing a unit on area and volume. And there's no time to look up formulas. The kids need to have them in the front of their heads. The same way for you guys, there's no time to sit and think about what 6 times 4 is. So certain elements of math need to live in the front of your brain all the time. And each of these formulas falls under those categories. If you can understand the area formulas for parallelograms, squares, and rectangles, if you can understand the area formulas for rhombuses, trapezoids, kites, and don't forget about our straight little triangle, that'll make you a more fluent mathematician. That'll make it easier for you to access the information that you need. And this stuff should be coming out of your brain without you going back to a packet, without you looking it up, and without you Googling it. So I'm going to stop talking, and on the front of this worksheet is this information about each of these shapes, and I want you to check out what's on the back. Blank space for you to add whatever you think is necessary. So do me a favor, turn to you, and I'm going to have 5 minutes of absolute silence in this room where you are putting your own content and information, and then after 5 minutes of silence, then and only then can you talk to a partner. Yeah?
Well, we need to use on the homework a few minutes ago. We really need to use trigonometry for
Anything that we learned in Unit 6 is fair game for Unit 7.
Okay.
So sine, cosine, tangent, absolutely. Some old hippie, 100%. Pythagoras, okie dokie. So triangle sum theorem, yep. Whatever that you had as far as determining, is it a triangle, is it acute right or obtuse, is it a parallelogram, what determines parallel lines, everything from all of our units is always fair game because it naturally folds into each next unit in geometry. That's why I love it so much. All right, 5 minutes of silence. You Marcus, say go. Finding the angle measures. For A, B, and C, all I need to do is add up the number of interior angles for each thing. And this is a pentagon, 1, 2, 3, 4, 5. So 3 times 180 is going to equal to those sums I saw for x. Here I saw for x using linear pairs, supplementary angles. Y, same thing, linear pairs, supplementary angles. But z, I need to add up all of those values to get its value. This one here, x minus 6 is equal to each of these angles. Somebody was in here talking to me about this the other day, and they're like, I thought that was the length of the diagonal, x minus 6. I'm like, you see that little degree sign? So there's a reason why the units matter so much. If you're having a hard time telling the difference between what's a line segment and what represents an angle measure, the degrees will support you in that struggle. Interior angles, what is the measure of 1? Exterior angles, any questions on page 1? Go, Molly.
For the one that you pointed out with the arrows,
Yeah.
I got 118 for x rather than 122. I'm not sure.
Okay, it is a hexagon, so 4 minus 6, or 6 minus 2 is 4. 4 times 180 is 720. Are we okay with that? I have 1, 2, 3, 4, 5, 6 x's. When I add 12 to each side, I get 720 plus 12. Did you get that? So 720 plus 12 divided by 6. Yeah, I still get 122.
Oh, I think I might have subtracted the 12 out of the half.
There you go. That'll do it. It is negative here in my equation, Molly, but then when I combine like terms and I put my constants together, it needs to be added. Awesome. Any other questions on page 1? Okay, page 2. These properties, and you've had so many different ways to process this information. List it all, list just the most specific. This one was kind of cool because it asked you to talk about which of these indicators counts as a definition. So our definition of quadrilateral is a polygon with 4 sides. Our definition of a parallelogram, our definition of a rectangle, our definition of a rhombus. But notice I can have a quadrilateral that is all of these conversations. So this one was a little weird when you're talking about name everything that's included or naming just the most specific. So thinking forwards and backwards can be tricky for sure. Here we talk about their properties. And of course this Mac Daddy that owns them all is our square. Our square is going to be all of the characteristics that are true for parallelograms, rectangles, and rhombuses. Any questions on this chart? Here we have determining your most specific name and then finding the measure of the angles. So any questions on solving these? Are we okay with those? Yeah? Go ahead, Molly.
How'd you find for like the first ones down the rectangle? How'd you find 3?
How did I find the measure of angle 3?
Yeah.
Okay, so with the rectangle, I've got,
Oh, the other.
not this one? This one, okay. So with this rectangle, I know I've got bisecting diagonals that are congruent. So that means that these top 2 triangles are congruent, these bottom 2 triangles are congruent. So the measure of angle 1 is going to be this vertical angle, the measure of angle 2 is that supplement. You're okay with that? Okay, so when I talk about 3, listen up, this might make a difference. You know how you're like, do we really have to remember everything? Yes. Do you see this isosceles triangle? That means that these base angles are equal. And usually somebody else goes, well, nobody asks you for this one. True, but I know that this plus this plus this is 180. So I solve for 3 by saying 116 plus 2x
Oh,
is equal to 180. So take 180 minus 116
sure.
and then divide that in half. And that's what 3 will be equal to. Sometimes you have to do more work than they ask. Sometimes you gotta find something that they didn't ask you to find in order to get 3. So you are always looking for congruent triangles, you're always looking for isosceles, you're always looking for equilateral, you're always looking for right. Everything we talked about in Unit 4, you're still looking for. Unit 5, congruent triangles. Similar triangles. Unit 6, right triangles. Like you are looking for everything to help you answer these questions all the time. Go ahead.
I don't understand how you found 2 for the rhombus.
2 for the rhombus. If
Yeah.
this one, if it's a rhombus, then these diagonals are angled bisectors. Done.
Oh, okay.
Right? Too much to remember. What else you got? All right. Next page. Proving parallelograms. There's our 6. We've already talked about them. Yeah, there is one of these on the test. So you absolutely need to know how to talk about givens, how to use the slope and distance formula to prove what you need. Your justification for your work is slope or distance formula. Therefore, the segments are congruent because the definition of congruent segments, or therefore the segments are parallel because parallel lines have the same slope. Then when you get down to therefore why it is whatever shape it is, then that justification happens too. If you're in doubt, ask yourself, if I said the word because, do I have more to say? If you think you've said it all, add the word because on. And if you've got more to say it. Yeah.
Does it matter if you put exactly one pair of parallel sides?
Yeah, because that's our definition of trapezoids. So if you're telling me prove this shape, you need to prove not only what it is, but what it's not. It's not a parallelogram because I don't have two parallel sides. It is a trapezoid because I have exactly one set. What else you got? Okay. For number 7, I went ahead and I found that each side length is the same, which means it's equilateral, but I went ahead and figured out the slopes, and I said the sides are not perpendicular, so it can't be a square. So that means it is a rhombus.
I was gonna say I found the distances of the diagonals and if they weren't congruent.
Perfect, beautiful. So any way that you could say it is this, but it's not this, is what we're looking for. If you can add a because on, keep going. What value of x makes it true? If it's a rhombus, this angle is going to be bisected. If it's a rectangle, these two pieces are going to be the same. If it's a rhombus, these two angles, careful here, the angles are going to be bisected, but these two angles added together are going to be complementary. The most mistake there is you set them equal to each other. And remember, for a rhombus, the angles are bisected, but not necessarily bisected the same. Think of a most exaggerated view of that shape. Nobody thinks that this obtuse angle, bisected, is going to have the same angle measures as this acute angle, bisected. But I know that they're complementary because what is the measure of this angle? Yeah, it's 90 degrees. Why is it 90 degrees? Because because the diagonals are perpendicular in a rhombus. Find the measure of angle 1 and 2 for that kite. Any questions on these? And this one, we don't have enough information because I can tell you what this angle is here that nobody wants. I can tell you this one. Anybody want this one? No. But with this, I don't know what this trapezoid's measure is. So that one is not enough information.
How would you have solved it?
If somebody gave me 1, I can give you 2 because they're going to be supplementary. But without more information, like let's say somebody said, "Oh, I forgot to tell you it's isosceles." Okay, now I'm in business. 1 is 74, and 2 is the supplement. But they didn't tell me it was isosceles, so I can't assume it. You with me on that? This system here, you can solve anything with one variable, but when you set these equal to each other and these equal to each other, you get this system here. I solve a system by substitution. I rename one variable in terms of the other. So instead of writing y right here, I wrote x plus 3, and that lets me solve. Are we good with that? Here's our formulas. We reviewed them again. Don't forget about your mid-segments on trapezoids. Those are the averages. Any questions on 10, 11, and 12? Go.
I don't really understand how to do 10, how to find the height.
10. It says an isosceles trapezoid ferrous, so I know that these two sides are going to be the same length, and I know these two base angles are going to be the same. It has bases of 14 and 20. So because this is 14 and it's isosceles, this 20 is going to be made up of 14 plus 6. So if I look at this here is 14, but the 6 I have extra is going to be evenly split between those. So then I got 3. Once I see 3 with a hypotenuse of 5, I can do Pythagoras to get my height of 4. Or it's just a 3, 4, 5 triangle that I have memorized. That's another thing that should live in the front of your brain.
What if it's not an isosceles trapezoid?
Can't do it. You can make right triangles and drop a altitude anytime you want, but you won't be able to do this even split of that difference unless you have more information. Go ahead.
I don't get how you found that.
How I found what?
Like the square.
The square. If I take this square and I draw the diagonal, I've given myself an isosceles special right triangle, x root 2. So I know that 10 is equal to my side length times the square root of 2. That's my special right triangle from last unit. So remember when I had an isosceles, right triangle where this is x and this is x and this is x times the square root of 2? So x is equal to, or 10 is equal to my side length times the square root of 2.
Why'd you do all the others? Is that like diagonal?
Yeah, check it out. If you wanted to do this one, I went ahead and did the side length and then I squared it. But a square is a rhombus. And the area of a rhombus is 1/2 the product of the diagonals. So I can do that again. A square is a rhombus. So that's what that is. Are we good? And then this one, is it a polygon? Yes or no? Any questions on this one? These answers were on the back of the review packet. Anybody want to talk about any from this page? Molly? All right. How about this page? Anybody want to talk about any of these?
You talking about 29?
29. Find the number of sides of a regular polygon with an interior measure. Hey, you can do this the easy way or the hard way. Which way do you want to do it first? It's a regular polygon, which means they're all the same. My interior angles are equal to 144. So I can say that my number of sides minus 2 times 180 divided by my number of sides is equal to 144 degrees. I can distribute 180, multiply each side by n, combine like terms, and solve for my number of sides. The easier way of doing that is recognizing that if my interior angle is equal to 144, what's my exterior angle? 36? Is that what you said, Ashley? 36 degrees. So the sum of all of my exterior angles is equal to 36. So if I divide 360 by 36, I'm going to get how many sides there are. See it? So easy way, red, hard way, blue. Do you want me to keep doing the math on the red way or on the blue way? Anybody want to see that math? Yeah? Okay. The first thing I'm going to do is multiply each side by n and distribute my 180. So 180n minus 360 is equal to 144n. You okay with me doing both those operations at the same time? I multiply each side by n. There he is. I distributed the 180s. You good with that? So now when I combine like terms, I have the opposite of 360 is equal to 144 and minus 180. So 144 minus 180 gives me negative 36 n's. So I'll divide each side by negative 36 and I get the same answer. Good? Yeah.
You do the same thing for 30?
Find the number of sides with the regular polygon. Yeah, if I have exterior angles that measure 35 or 45 degrees, once I know it's regular, 360 divided by those 45 is going to equal to my number of sides, always. Then I can't do it. If it's not regular, I can figure out totals, but not individuals. What else you got? Make sure you have a calculator. Clear your desks, except for this.
Yes!
Go.
Oh my god.